Welcome to CMSC202. This is Ali Chavez. I'm here to discuss the topics for our assignment number 3, which are the functional programming, object-oriented programming, and the modularity. Let me start with topic number 6, which is functional programming. Let's define functions first. Functions are values which can be assigned to variable or can be passed to other functions. If in our previous topic, we already discussed functions which we use for loop and switch switch case examples. So here we'll use it for the functional programming, in which produces abstractions through clever ways of combining functions. And these functions that operate on other functions, either by taking them as arguments or returning them, are called higher order functions. And these higher order functions can be used to generalize many algorithms that regular functions cannot easily describe. Here are the advantages of using functional programming compared to the regular that we use, the for loop or the switch case. We can express things in a shorter and clearer way, and we can write a program in less time. Since it's a short code, then it's a less time. And we can write the program with less bugs also. And these codes or algorithm are usable code. Here are the examples of methods that can be used for functional programming. The map method, which is creates a new array with the results of calling of functions for every array element, while filter method is used to create an array filled with all array elements that pass a test, provided that the callback function is a function. And the reduce method reduces the array to a single value and execute a provided function for each value of the array from left to right. Here is an example of map method which creates an array element that results of calling a function for every array element. So let's find the area of the circle in each radius in the given array. So the given array has 5 elements, and using map method we can calculate the area of the circle in each element of the array. So using the syntax of the map, radii, which is the array element, that map, which is the method, and the callback function, which compute the area of the circle of each element of the array. Notice that the callback function has open and close parentheses. So make sure this is here, because if it is removed, uh, the output will be undefined. So let's output the result. Will be the new array of the circle of each element. And I use the to-fix to remove the decimal places. Let's go to the next topic, which is the object-oriented programming, which is a programming paradigm that uses abstraction to create models based on the real world. And it envisions software as a collection of cooperating objects rather than a collection of functions or simply lists of commands. One of the advantages of using object-oriented programming, or OOP, it promotes greater flexibility and maintainability in programming. And this is widely popular in large-scale software engineering. Compared to C++ or Java or other modern programming languages which uses class for OOP, JavaScript is a prototype-based language and contains no class statement. Instead, JavaScript uses functions as a constructor for classes. Here is an example for an empty class of a car. A constructor is a method called at the moment an object is initiated. It is usually has the same name as the class containing it. Like for example here, so we have a class or constructor with the name car. So we can call a new variable. We can using the new keyword. We can call the car function to create a new variable. And it is considered a good practice to name constructor function with the uppercase letter. You can notice that the car function has a first letter uppercase, while the regular variable has a small letter. So we can add a property inside the constructor. A property is a object characteristic. So for example, we want the name of the car, so we can state that using the keyword this, we can create the property name. And we can call the constructor with the new name Toyota Corolla and can output with the new variable car1. So this can be outputted as this is plus car1 dot name, and it will log as this is Toyota Corolla. The same thing as for car number 2, which is the Mitsubishi Montero. The this keyword is in an object constructor does not have a value. It is only a substitute for the new object. The value of this will become the new object when the constructor is used to create an object. So here, the property name, and we call it for car number 1, we call it as Toyota Corolla. And for car number 2, we call it as Mitsubishi Montero. We can also add methods in constructor. Methods are an object capability. So for example, here in our car, we can add car.prototype.drive equals to the function that this car or the name of the car can drive up to 180 kph. So we are using the prototype keyword, which allows us to add new property. Even we can add new properties and new methods to an existing prototype. So let's call again the, the car while using Corolla. So if we state that car1.drive, make sure that this has a parenthesis, it will logs Corolla can drive up to 180 kph. The same thing with Montero Sport. Make sure that this open close parenthesis is here, because if it is removed or it's not there, it will be undefined. There are some ways or techniques that we can use for object-oriented programming. One of it is the encapsulation. Encapsulations is like encapsulates or contains data in an instance of a class from another instance of the same class. And it supports data hiding and the content of viewing object. as self-contained entities. The next one is inheritance. Inheritance is a way to create a class as a specialized version of one or more class. And the specialized class is commonly called the child, and the other class is commonly called the parent. So inheritance is like a parent-child relationship, while for encapsulation, it's from one class to another. The third one is the polymorphism, which is from the word poly means many and morphism means form, so many forms, which is different classes might define the same method or property. This is an extension of principle of inheritance and implemented using prototype operator also. Because in JavaScript, you can only have a single inheritance. So to have, if we need to use it program with, we need to more define more property or method, so we can use this polymorphism. So it is also where a subclass of a class can call the same generic inherited function in its own context. Topic number 8, modularity or modules, which is defined as define programs into cluster of codes that belong together. A good example of this is our eloquent reference book, which is the author subdivides topic by its purpose. So, like for example, our topic 6 is functional programming, topic 7 is OOP. But the good modules are highly self-contained with distinct functionality, allowing them to be shuffled and removed or added as necessary without disrupting the system as a whole. So for example, if we want to change something in functional programming, even you add or remove some stuff inside there, so it will not disrupt the other topics or chapters. But so why module self? So we can say because of the maintainability. It's by definition is a module is self-contained, and a well-designed module aims to lessen the dependencies on parts of the code base as much as possible so that it can grow and improve independently. So, like for example, again on the book, so even if we want to change something on one chapter, it will not affect the other chapter. So we can improve or we can edit something that can improve the chapter. Number two is the namespacing. In JavaScript, variables outside the scope of a top-level function are global. So it's as we said, global is you can see it everywhere. Global variables. Because of this, it's common to have namespace pollution, where completely unrelated code share global variables. So by using module, we can use this function. As you can see, there is an enclosed parenthesis. So using this enclosure, uh, we can hide this function in the global variables. In number 3, it is reusability. And if we put pieces of functionality that stand on their own into separate files and modules, so it's easier for us to track, to update, and share it to other files or a program. There are two popular and well implemented approaches in modules. These are the CommonJS module and the asynchronous module definition. CommonJS module is a reusable piece of JavaScript which exports specific objects, making them available for another module to require in their programs. While AMD is a JavaScript specification that defines an API for defining code modules and their dependencies and loading them asynchronously if desired. That's it. Thank you.